Welcome to this explainer. Today, we're going to pull back the curtain on a truly fascinating era of history. You know, when we trace the story of human progress, we almost always hear about the wonders of ancient Greece, right? And then we kind of just skip right over to the brilliant dawn of the European Renaissance. But there's this massive, nearly 6th century missing link between those two iconic eras that literally built your modern world. So let's dive into the hidden origins of modern science during the Islamic Golden Age.
We constantly credit ancient Greece and the European Renaissance for human progress, and for good reason. But nestled right in the middle of those two periods is a pivotal 600-year foundation. While Western Europe was navigating the absolute turmoil of the early Middle Ages, Muslim scholars, mathematicians, physicians, and astronomers were incredibly busy. They were translating ancient knowledge, testing brand new hypotheses, and constructing the absolute bedrock of our modern technological world.
Okay, let's look at this timeline. Spanning roughly from the 8th to the 14th centuries, this was an era when cities like Baghdad, Cairo, and Cordoba essentially transformed into the intellectual capitals of the planet. By the 9th century, this intellectual explosion gave rise to the famous House of Wisdom in Baghdad. And by the 12th century, all this massive wealth of knowledge started transferring over to places like Toledo. But what exactly were these scholars discovering?
Well, here is our roadmap. 1. Optics and the scientific method. 2. Algorithms and algebra. 3. Revolutionizing medicine. 4. The birth of chemistry. And finally, 5. Engineering and legacy. Starting off with Section 1, Optics and the Scientific Method. Let's look at Ibn al-Haytham's reality.
Let's actually start with something you probably use every single day, the camera in your phone. We can trace its origin straight back to an 11th century pioneer from Basra named Ibn al-Haytham, who was known to the Western world as Al-Hazan. See, before the 11th century, ancient scholars like Ptolemy heavily relied on intuition. They actually theorized that human eyes emitted light rays to see objects, kind of like laser beams, right? But Ibn al-Haytham completely rejected this idea. He conducted rigorous, repeatable experiments using completely dark rooms and pinhole apertures, what we call the camera obscura, to prove definitively that light actually travels in straight lines and reflects off objects into our eyes.
And you know, this brilliantly illustrates his absolute greatest gift to civilization, the modern scientific method. He didn't just stop at observation. He established that any scientific theory must be rigorously proven through a very specific framework. You have to gather empirical evidence, provide mathematical proof, and demand experimental verification. Before him, science was basically just philosophy. He provided the rigid framework that defines how we do science to this very day.
Moving on to Section 2, Algorithms, Algebra, and Zero. We're talking about Al-Khwarizmi's mathematics.
Now, this strict insistence on proof and logic builds directly into the mathematical architecture that powers all of our modern computing. Which brings us to a question I want you to think about. What invisible, underlying mathematical force dictates every single post you see on your social media feed and runs literally every software program you use today?
The answer, of course, is the algorithm. And fun fact, the word algorithm itself is actually a direct Latinized translation of the name Algoritmi, which comes from Muhammad ibn Musa al-Khwarizmi. He was an absolute genius working at Baghdad's famous House of Wisdom back in the 9th century. Honestly, it is entirely impossible to discuss modern science or computing without mentioning him.
He completely revolutionized how humanity works with numbers. He introduced the Hindu-Arabic numeral system to the wider world and formalized the whole concept of zero, replacing those incredibly cumbersome Roman numerals with a streamlined positional system. He also systematized linear and quadratic equations. But his most famous achievement? A landmark book titled Kitab al-Jabr, which literally birthed the entire branch of mathematics we know today as algebra.
All right, let's jump to Section 3, Revolutionizing Medicine and Surgery, focusing on Ibn Sina and al-Zarawi.
Next up, we're uncovering the hidden origins of organized healthcare. During this era, Muslim physicians turned medicine into a highly research-backed discipline, heavily supported by public hospitals called bimastans. And out of this era came a staggering number: 500 years. Think about how fast medical textbooks go out of date today. But 500 years is exactly how long Ibn Sina's massive 14-volume encyclopedia, known as the Canon of Medicine, remained the standard medical textbook across European universities. He essentially synthesized all known medical knowledge of his era, and its impact was just monumental.
The real-world impact of these pioneers was absolutely revolutionary. Ibn Sina was among the very first to recognize the contagious nature of airborne diseases, identify the psychological components of physical illness, and, get this, propose strict quarantine procedures to stop epidemics. Meanwhile, working at the same time over in Islamic Spain, al-Zaharwi was designing over 200 distinct surgical tools. He designed many of these himself, like bone saws and forceps. He also pioneered the use of dissolvable catgut threads made from animal intestines for internal surgical stitches. It sounds crazy, but it's a technique that is still referenced and utilized in modern hospitals today.
Which brings us to Section 4, the birth of chemistry, and the legendary Jabir ibn Hayyan. This fourth stop takes us away from the mystical, philosophical attempts to turn metal into gold and directly into rigorous, measurement-based science. Jabir ibn Hayyan, who was actually known in the West as Geber, systematically transformed alchemy into a true, verifiable science. See, before the 8th century, alchemy was mostly just a mystical mix of philosophy, but Jabir emphasized exact measurement and laboratory experimentation. He firmly dragged chemistry out of the philosophical realm and straight into the lab where it belonged.
He essentially invented and perfected fundamental processes that are still used in literally every chemistry lab today. Things like distillation, crystallization, evaporation, sublimation, and filtration. Plus, he was the very first scientist to isolate and synthesize strong mineral acids like hydrochloric, nitric, and sulfuric acid. These discoveries form the absolute backbone of industrial chemistry centuries later. It's a real game changer.
Finally, let's head into Section 5, Engineering and Legacy, highlighting al-Biruni, al-Jazari, and the Renaissance.
Let's zoom out from the laboratory for a second to see how these scholars actually measured the globe and engineered machines that shaped daily life. The master polymath al-Biruni looked outward across the planet. Using complex trigonometric equations and a single mountain peak in modern-day Pakistan, he calculated the Earth's entire radius, and his measurement came within a breathtaking 1% of the actual modern value. 1%. It is truly astounding accuracy for the time.
Meanwhile, over in the realm of engineering, innovators like Ismail al-Jazari were creating incredible mechanical devices. We're talking water-powered clocks and automated hand-washing basins. But his most absolutely crucial engineering marvel? The crankshaft mechanism. Al-Jazari created this mechanism to seamlessly convert rotary motion into linear motion. If that sounds familiar, it's because that is the exact core mechanical concept that powers every single modern internal combustion engine today.
So what actually happened to all this knowledge? Well, these scholars didn't just preserve old Greek ideas. They ignited an absolute wildfire of new ones, rigorous testing, and practical applications. In the 12th and 13th centuries, scholars from all over Europe traveled to huge translation centers in Toledo and Sicily. They translated these Arabic scientific texts into Latin, and this massive transfer of knowledge directly fueled the scientific revolution, and ultimately sparked the European Renaissance.
So the crucial point I want you to take away from this explainer is this final provocative question. The next time you solve an algebraic equation, or take medicine to treat an infection, or use a camera, or even just casually scroll through an app powered by an algorithm, ask yourself, whose ancient legacy are you holding in your hands right now? Their unwavering insistence that truth must be uncovered through reason, observation, and rigorous experimentation remains one of the greatest gifts ever given to human civilization. Thank you so much for joining me to explore the incredible legacy of the Islamic Golden Age. Keep learning, and I'll catch you next time.